Welcome everyone to our third keynote speech at this conference. My name is Jack Cho, a professor at NUS Department of Communications and New Media and the co-chair for this forum. I cannot be more thrilled to present to you Professor Noshir Contractor, whose keynote address is entitled Reimagining Theories and Methods to Understand and Enable Algorithmically Infused Challenging Nature of Work. Professor Contractor is the Jane and William White Professor of Behavioral Sciences at Northwestern University, where he holds joint appointment in 3 schools: the McCormick School of Engineering and Applied Science, the School of Communication, and the Kellogg School of Management. A truly interdisciplinary scholar, Noshir directs the SONIC research group. SONIC stands for the Science of Networks in Communities. Prolific and impactful, Noshir has received many important awards, a recent one being the 2021 Fellows Book Award from ICA, International Communication Association, recognizing his co-authored book, Theories of Communication Networks, as a true classic in our field. The International Network for Social Network Analysis has also recently selected Professor Contractor as the recipient of the very prestigious CIML Award in 2022. Congratulations. In addition to his preeminent research achievement, Noshir is also an exemplary community builder and educator. He is the president-elect of ICA, for which I have the pleasure of serving as his co-chair for next year's ICA annual conference in Paris. Particularly humbled and honored I am today because in the spirit of social network research, I have to disclose that I took Noshir's class 21 years ago, which was my very first encounter with network analysis. Not only the theories and methods, but also the tools, especially UCINet, pioneering social network analysis software at the time. Later, I benefited from SONIC training workshops myself, and I have always been looking up to Noshir as the role model to emulate in my research, teaching, and services. Finally, I'd also like to note that Noshir grew up in India, where he used to work in the TV industry. And his bachelor's is from IIT Madras. It's a pity we cannot have you physically back in Asia due to the pandemic, but I hope we can bring you to our beautiful NUS campus at another occasion in the near future. Without further ado, please join me in warmly welcoming Professor Noshir Contractor to deliver his keynote address. Well, over to you, Noshir.
I want to thank you, Jack, for that very, very kind introduction. I'm sure that my mom, was she to be living, would be flattered. And of course, my dad would tell me not to believe any of it, and he would be right. I also want to thank all of you for giving me this opportunity, this invitation. I look at the list of speakers that you have, and they are truly a phenomenal set of speakers. And I'm very privileged and honored to be included as part of this conference. I have been to National University of Singapore. I've been to Singapore on multiple occasions. In fact, I believe that one of the more recent times I was in Singapore was on the day Steve Jobs passed away. I remember landing at the airport and hearing the news, and it was quite amazing. And I look forward to coming and visiting you all in person in the not too distant future. And I certainly hope many of you, especially those in the field of communication, would consider what we still hope will be a hybrid conference anchored in Paris for the International Communication Association that Jack mentioned in May of 2022 in Paris. And so perhaps I'll have a chance to meet some of you there. On with the program for today. My talk today is titled Reimagining Theories and Methods to Understand and Enable the Algorithmically Infused Changing Nature of Work. I know that's a mouthful, and I will try to unpack that piece by piece and give you a little bit of understanding of what we mean by the changing nature of work in terms of technology, in terms of algorithms, and then talk a little bit about what those changes might look like. I will, in the interest of time, also focus a little bit on some of the work that we have done ourselves at a very high level to give you some idea of what these things look like. And then I'm hoping to end with a few of the insights that let me see if I can get the chat side here. Yeah. Okay. I also want to end by talking a little bit about a summary of an article that my co-authors and I published in Nature just last month. And so let me make sure I try to see as much as I can get done in the interest of time. Jack, do you want to give me a sense of when to open it up for Q&A?
Yes, in about the hour. Okay, I will remind you when we get close to that point.
That's what I thought you would say. Good. Okay, so here we go. So if you look at the history of technology and the changing nature of work, a lot of those changes started in the 1990s. And a lot of these changes that we have been able to map started with something that was called groupware to distinguish it from software or hardware. And that led to the creation of intranets that many of us studied. You had new websites like Yahoo that were coming up at the time. LinkedIn, Threadless were in the early part of the 21st century. Many of us were studying teams, not in real world organizations, but in online games like World of Warcraft. The concept of social computing came on the table. Microsoft introduced their first sort of company-wide sharing systems called SharePoint. We saw the development of technologies that many of us still use, things like Dropbox, like Office 365, Google Drive. This was when the cloud suddenly became really important. And then we began to also focus, starting with the introduction of the mobile phone, to many sort of mobile applications, taking work to be much more mobile. And that's when you saw things like WhatsApp and Messenger develop. And then finally, more recently, there's been a lot of interest in crowdsourcing. That is the ability to get work done by large crowds. Most recently, we've seen also the development of something that is called as enterprise social media. These are things like Workplace, like Slack, like Zoom, like Microsoft Teams, and so on. So if you look at it today, some of the most current enterprise social media that we see are those that are shared on the screen. I wanted to give this introduction, this historical introduction to what is happening in the workplace in particular, because I want to help you all understand why these technologies have been disruptive in the workplace. They're not simply substitutes for the old memos that we sent via typewritten memos that we sent via the mail in the company, but are now changing it. And a lot of this has been brought about, or at least studied in the field of communication through the lens of what we call technological affordances. So let me give you an example of some of the technological affordances that have changed the nature of work, and in particular, the technological affordances provided by ESM, which stands for Enterprise Social Media. Some of the people who have been very influential and thought leaders in developing this in the field of organizational communication are cited at the bottom: Ron Rice and his colleagues, Jeff Treem and my friend Paul Leonardi, collaborator as well. And so one of these, what do we mean by affordances? For example, association. When you use ESM, when you use Slack, when you use Microsoft Teams, or for that matter, when you think about how you use things like Facebook or Twitter, one of the things that changes disruptively is the sense of association. These media, by virtue of being social media in the enterprise or in the general public, they help reveal who knows who. By looking at the feed on a wall, you begin to understand, you can associate people with knowledge or expertise or skills they have, what interests they have, as well as who they know well. Second, you're able to evaluate it, because now not only are you looking at information and evaluating other people's information by yourself, but also via recommendations, comments, liking, or tagging. Third, it makes it more visible. See how people have responded to questions raised by others. These are all things that we were not able to do before social media. Even plain computer mediated communication did not make this easy to accomplish. Fourth is persistence. When we began the session, you heard the recording button come on. That's a situation of finding information about prior interactions, decisions on a project, even if you're not in the same time zone or in a comfortable time zone, to be able to watch, for example, this presentation. The next would be examples would be things like personalization, where we see how people choose to present themselves, the presentation of self in everyday work life, including the information, photos, and other contents that they present. Let's continue for a few more of this. Well, let's do 5 more technological affordances. Editability, the ability to revise information others provide after they have shared it. This is something that is relatively new, and you don't no longer bound by saying, oh, I've sent this message, there's nothing I can do to revise it. The second is pervasiveness. I talked earlier about how mobile has now transformed the workplace. And indeed today, for better and for worse, we send and expect responses and requests from others quickly, round the clock, because we are able to see all of these things on our mobile devices. Awareness, you need to be aware of the information and updates from others. So that even if you're not directly involved in something, you are now aware where that person is, what that person is doing, what their accomplishments are, what they are thinking about a certain kind of issue, and you get a quick window into everyone's life without having to directly need to talk to them about it. Searchability. When you want to go back and look for information about things. Today, we tend to rely very, very heavily on search as a way of being able to quickly string together a series of events or activities associated with an issue. And then finally, and perhaps most commonly, sharing. That is, we create groups, channels on the fly for sharing information. So these are ad hoc groups that we are creating purely for perhaps some ephemeral purposes for a short period of time. All of what I have talked right now is fundamentally disruptive to the way we organize and the way we communicate in the process of organizing. The same thing has now been joined just within the last few years by what I call algorithmic affordances in the workplace. This is when the software is no longer just a tool, not even just an assistant, but becomes an actual co-worker, or in some cases becomes your manager. As this cartoon says, so the software, does it tell you to do things? Has it become your manager in this process? And what we see is that algorithmic affordances are having even more profound effects, not only on the way we work, but how we think about doing research about the way we work. This article on the left is the article in Nature that was published last month. The article in the right was an article that we wrote in Science magazine on the 10th anniversary, so to speak, of the original computational social science article that we wrote. That original article also included, amongst other authors, the presenter yesterday, Sandy Pentland, and so did the one that we published last year again. As you can see, also included Sandy, along with a whole set of other articles. I will come back and end with some lessons from the Nature article, but for now, what I want to do is take us through an example, a very concrete example of what we mean by algorithmic affordances in the workplace. An example is we are interested often in forming teams. If you think about it, algorithms have transformed the landscape of dating. Online dating has become quite standard, where we can swipe left and swipe right and look for people. That same idea that if we can use algorithms to help us find dates online, why can't we use algorithms to help us find teammates online? And so if you think about it, there is a continuum between user search, when we like to find our own teammates, and algorithmically formed teams on the right-hand side. And then, of course, we know that in some cases, the teams are formed by someone else. A manager forms a team. In other cases, people self-assemble. In academia, when we decide to collaborate on something, we often self-assemble into teams. But when I talk to my colleagues in space, for example, astronauts don't self-assemble. There is an astronaut staffing office that staffs exactly which astronauts are going to go on a particular mission. So if you look at these two dimensions, most of what happens today is in this dimension of ad hoc teams. Teams are assembled by a user. A manager puts them together thinking, I think A, B, and C will work well together. We in academia and other places do self-assembly research for people based on what we might think. But increasingly, we see that there are tools here that are algorithmically driven, where users receive recommendations from the system and team builders are also putting together teams based upon this. I'll talk more about these results later, but just to give you a preview right now of a study that some of us did in our lab and published last year, we look to see how platforms can change teaming behavior. So we know that if left to their own devices, people will choose people like themselves. Homophily, we tend to choose people on our team who are like us. Of course, we want people on our team who are competent, who we would want to go through because they have the skills that we need. We also know from prior work that people tend to choose others who they have previously worked with. This reduces uncertainty. I know who these people are. I know how they work, etc. The one that is of interest to us is, how does it change if the technology platform based on algorithms gives you a recommendation on who you should team with? And more importantly, how does that change happen when you already know the person? I'll give you a sneak preview. There are results later on, but I'm not going to hold you in suspense. It turns out all of these things are true. Even when you give people a platform to create teams, just like an online teaming platform, analogous to an online dating platform, they choose people who are competent. They choose people like themselves, even though they're given the technology. They choose people with whom they've had prior collaboration. However, they do choose people whose search results show up on the top. This effect is a strong effect. People are listening to these recommendations. Interestingly, they are more likely to listen to a recommendation of a potential teammate if that is someone we did not know before. In other words, if we did know someone before, the recommendation platform, the algorithmic recommendation, carries less weight. It still carries some weight, but less weight than if we didn't know someone. So while we like algorithms, we only rely on them more when we don't have prior knowledge of our own about this person. Okay, so I think with that I've given you an idea of how these technologies, whether it's the technological affordances or the algorithmic affordances, are having the potential of changing in fundamental ways the way we work, which brings us back to the title, Reimagining Theories and Methods to Understand and Enable the Algorithmically Infused Changing Nature of Work. The first thing it does is it reimagines theories. Today, we are able to study theories at scale that we were not able to do before. And that is something that is really important. For decades, we have had in the field of social networks, for example, that we know that people who are brokers tend to be upwardly mobile. And most of that work has been studied in very small organizations or relatively small organizations. But today, because of the kind of approach we have, the kind of data we have, we can study those kinds of phenomena and develop to check whether these theories really work at scale. This article that was published about 4 years ago by Sinan Aral and his colleagues in Nature Communications showed that we were able to show that exercise is a contagious process in a social network. So they were able to see that I am more likely to exercise if people in my social network exercise. But wait, there is more. That seems quite obvious to say, okay, well, that shows us that our old theories about social contagion, for example, were true. But what they found that was a nuance that we had not seen before in the literature and that made it unique was there was a nuance to the theory. You're more likely to be motivated to exercise if the people in your social network are slightly behind you and getting close to your fitness. In other words, you're more scared of being overtaken by people in your social network. That motivates you more to be able to do things. Not as much by people who are ahead of you. The normal idea in social influence is that you will aspire to the people ahead of you. If one of your friends is doing more exercise than you, that will motivate you to do more exercise. What they found instead was the opposite. You were more motivated by the fear of being overtaken by someone than the desire to overtake someone, for example. Another example of reimagining theories is looking at things like what are the optimal incentives for collective intelligence? So this was an article that was published that allows us to see how theories that are focusing attention on new or at least increasingly prevalent phenomena. So the entire idea of collective intelligence has only been sort of mushroomed in importance now. It's not to say that collective intelligence didn't exist decades, maybe even centuries ago, but certainly our ability to harness collective intelligence, to mobilize collective intelligence. Likewise, our ability to engage in team assembly, like the kind I just gave you as an example, where people are teaming together in flash teams at a moment's notice. These are new phenomena. And we need to have theories that focus attention. So while the previous example was being able to test existing theories at scale, this is now focusing our attention on coming up with new theories for relatively new phenomena, such as collective intelligence and team assembly. The third kind of reimagining is theories that invite consideration of new combinations of variables. It's a well-known fact that we tend to think about theories based upon variables we have measured. But today, the ability to come up with new combinations of variables. For example, today, there's a lot of interest in seeing how we might be able to understand social network structure, not just based on the kind of old traditional variables of social networks, but to also think about new variables. Why? Because today we are increasingly able to study brain connectivity. And as a result, the ability to measure brain connectivity and the dynamics associated with brain connectivity has now allowed us to come up with new kinds of theories where we are explaining our social networks based upon brain connectivity, and we are explaining brain connectivity based on our social networks. These are new forms of explanation that are made possible by new combinations of variables. Just like theories, we're also reimagining data. We have today large digital trace data repositories where we have actions, interactions, and transactions. And for a long time, this was data that existed in the wild, so to speak. It was not data that was created for the purpose of research. In a project that we have concluded now, colleagues at USC, at Illinois, at Minnesota, at universities in China, and we have been working very closely together to see what we can learn about what work life might mean by looking at online gaming environments such as Second Life, World of Warcraft, the Sony EverQuest 2, which is this one right here. And we learned a great deal by simply looking at the actions, interactions, and transactions within this world. Some of the challenges, the data was not, the log data that we got was not created for the purpose of research. It was created by computer programmers to debug the system in the event of a problem. Later, it began to be collected for marketing purposes so that the game developers could learn how they could sell their product more. But nonetheless, there was still what we would call digital exhaust or digital trace data that has been helpful to us. The second is data that is collected from crowdsourcing data from people unintentionally from enterprise social media platforms. So they are, in the past, people were able to just look at these kinds of data. They looked at connections on IBM, which is one of their internal software programs. They look at competition sites. The goal was not to collect data for us to study it, just like in the previous case, but it was because people were engaging in enterprise social media platforms. That is now changing. If you look just within this past year, Microsoft created now within Microsoft Teams, they realized that Microsoft Teams is not just useful to help people interact, but the digital traces that are there on Microsoft, who's talking with whom, who's chatting with whom, who's following whom, who's at mentioning whom, provides new additional insights. And so they have now created within Microsoft a unit called Microsoft Viva, where the idea of Microsoft Viva is to take the data that you are using on Microsoft, your own actions, interactions, and transactions. They analyze it and give you new insights about your work style, when you should take a rest, who's in your social networks, when you should reply, are you having burnout, are you having profiles, or when you might be sending too many messages or people you're not responding to quickly. These are all insights that are captured by the digital trace, mostly metadata that you've created. As I mentioned, Kaggle is another place which is supposed to be a place for having data mining competitions, but that can also be used to understand the nature of successful teams, what teams are successful, because in the process of having these data mining competitions, you are unintentionally collecting a lot of data that differentiates successful teams from unsuccessful teams. You've already heard a lot about sociometric badges. People like Sandy Pentland have been at the pioneering. This was a badge that he and his colleagues have developed to see how he could study what is happening between team members without having to ask them. So relatively unobtrusive ways of capturing data about the energy within a team. Likewise, we mentioned earlier that people are now having neurosources, which doesn't always mean that you have to put them into one of these MRI tunnels. Today, more and more, there are relatively unobtrusive ways of being able to get neuro data, or what they call more generally physio data from individuals, by simply relatively unobtrusive, not yet completely unobtrusive, but relatively unobtrusive ways of collecting that kind of neuro data. And then, of course, we've all spent time on getting data from people intentionally by having experiments on Amazon Mechanical Turk. My friend David Lazar and his colleague Jason Radford have actually started a platform called Volunteer Science, where people can go in and contribute play in activities, but the result of which is you're helping develop science. And then the platform that we have developed here at Northwestern University in my lab called My Dream Team, which is a platform that affords individuals the ability to come up with teams. This was exactly the teaming platform that I was mentioning earlier. But in the process of doing that, we are able to study something we were never able to study before. And that is how teams come together. Most of the work until now was done after a team was formed and we looked to see who was a successful team. But now, by seeing how people search for other people, what they, who they invite, whose invitations they accept, and how that team forms, that entire process now becomes available to us because people are using platforms like My Dream Team that allows you to do that. I'm not going to spend much more time talking about that right now. One last example, which is sort of funny, and that is an example of how a game that some of you may have heard of called Where's George has contributed dramatically to our understanding of infections, starting with the flu, but also all the way up to the COVID. Not many of you may be familiar with. I would encourage you to take a look at it. But this website is called where'sgeorge.com. And the George in Where's George refers to the $1 bill that has George Washington on the bill itself. And somebody started a website more than a decade ago, I believe, saying, they stamped dollar bills with this and they gave it to people. And they said, if you get a bill that has the where'sgeorge.com website stamped on it, go to the website and enter the serial number of this dollar bill. And you'll find who else may have entered it previously, and then just enter your location. What did that do? What that did was it all of a sudden made it possible for us to see that today this dollar bill was entered in Evanston, Illinois, but 3 days later, that same dollar bill was entered in Seattle, Washington. And then 4 days later, it was entered in Dallas. What is this telling you? And so everyone thought this is a funny game. You see this output that you see on the screen, etc. But one of my former colleagues, Dirk Brachmann, who's an applied mathematician, physicist, now in Germany, he saw this differently. He saw this as a great opportunity to study mobility networks. Because as you look at the traveling of the dollar, you begin to take that as a sign of where people are traveling from, which town to which town. And he used that to write this article that appeared in the New York Times back in 2009, where he was able to predict the spread of flu with the aid of the Where's George website, because the Where's George website gave him a really good mobility network map of the entire United States. He's continued to do this and use it even in the context of previously H1N1, but now in the context of COVID as well. So again, you see how sometimes you have to be creative where you find data. And finally, people don't think of the lab as providing you big data, but in all the work that we've been doing, an article that we wrote 6 years ago, where we said little teams, big data. Big data provides new opportunity for teams theory. So we see that not only do we have self-report data, but we can combine it with server logs when people are using it, as well as chat logs of what people say. So what people see and do, what people say, what people feel, what people think. This all provides you actually a very large amount of data from a very small team that comes out there. And then finally, we need to reimagine broad data. My colleague James Hendler, who's a professor at Rensselaer Polytechnic Institute, said, we have to move. And he said this quote, the end of big data is the era of big data is so 2012. Today, we've entered the era of broad data. And what does he mean by that? It's not just getting more of the same data, which is how we think of big data, but broad data is the juxtaposition of different types of data. It is the combination of a variety of different types of data that can provide us really broad insights, and Jim refers to that as broad data. Finally, we talk about theory, we talk about data. I want to talk quickly about methods. So for example, I'm just going to give you a few quantitative method examples. Just to clarify, this is not to suggest that there are not other approaches that are incredibly valuable and necessary. But again, just to give you a quick example, until recently, people who studied networks either studied cross-sectional networks or studied networks as dynamic. When they said dynamic networks, they meant a network at time 1, a network at time 2, a network at time 3. But today, when we collect all this timestamp data, the first thing that I did about 10 years ago, and I'm ashamed to even admit this, is that I would take this timestamp data which said A talked to B at 10:01, C talked to B at 10:02, and then A talked to C at 10:03. I would collapse that data to create a network for the 10 o'clock hour. And then I would create another network for the 11 o'clock hour, and I would study the network dynamics. Why? Because the only methods that existed to study network dynamics were taking a network at one point and predicting a network at the second point. But today, because of the kind of high resolution data we have, the field of social network analysis has absolutely mushroomed in the development of a new technique that says, forget about networks as they are. Think of them as a relational event. Each event that happens, every time step is a relational event. And today, relational event modeling has become a center stage of social network analysis. 10 years ago, there was one session at the Social Networks Conference. Earlier this year, in the virtual conference, there were over 60 sessions focusing only on relational event modeling. You can see how this has now reimagined methods. Another example, until quite recently, people who studied teams from a network point of view described a team as a network links between all the members of a team. But if you have 3 members in the team and you show network links amongst those 3 members, you have no way of knowing whether this was a 1 3-member team or 2 or 3 separate 2-member teams. So today we have now made the leap and gone from looking at teams as just graphs or edges on networks to a hypergraph, where a link doesn't exist just between 2 nodes, but you can define this edge here as a link that exists between 3 nodes, V1, V2, and V3. So this is one 3-person team represented by edge 1. This is one 2-person team represented by edge 2. This is another 3-person team represented by edge 3. And this is a 1-person team, if you want to call that a team, represented by a single edge. Again, just to give you a sense of how this is changing. Another way methods are changing is computational models. We might have a chance for me to give you an example of this, but if we don't, today, increasingly, we are able to take situations where we take a human set of individual data, but take it into a computer where we create simulations of each individual. So this is a simulation where we have 4 astronauts, and we are trying to model who likes each other, who thinks one another is a hindrance, who has good coordinates well with others, and who is good at sharing information. And we take data from an actual observed study that we are doing at the NASA Johnson Space Center, where they put 4 astronauts into isolation for extended periods of time, 45 days. And some of the research we've been looking at in NASA in collaboration with the Russians is over 120 days, 240 days. They put them into isolation. We study them, we understand how they get along, and then we build computer models. And what has been so exciting in computational modeling is we are now able to build computational models that predict which 2 team members will get along or will not get along on which particular day. Think of this as weather forecasting, but applied to the context of teams. And finally, I think it's really important to move away from some of the things I learned in my very first methods class as a graduate student. And that is, don't just take data and explore it. That's dust bowl empiricism. You can always read tea leaves at the bottom of a cup of tea where you can see anything you want. Today, I think we've reached a point where we have to combine theory-driven and data-driven approaches. We have to move beyond deductive approaches and inductive approaches to what we argue are abductive approaches, which is the iterative amalgam of being able to take theories to look at data, but then rethinking theories in light of what we find in the data, see how we can do this, not just with traditional exploratory techniques, but also machine learning and other kinds of techniques. Because one of the things that it tells us is machine learning doesn't just give a hypotheses of the kind we typically think of in the social sciences. In the social sciences, the hypotheses are very often based in some kind of either correlational situation or an ANOVA situation. By that I mean, as X increases, Y increases or decreases, or we find differences in values of P based upon whether they fall into condition 1 or condition 2. But if you look at the ways in which machine learning algorithms work, they often give you hypotheses or insights that don't fall into those kinds of categories. Instead, they fall into heuristics. In other words, I can tell you whether somebody is dead or survived based upon what probability that they were male or female, based upon whether their age was more or less than 9.5, and then whether they had siblings, etc. So we have these various if-then statements, which we don't typically look at. Our theories don't hypothesize if-then statements. But now with these approaches, we have new ways of thinking about asking the questions we want to ask. One final cautionary note. We have heard that we always are driven by where the data is. For many years, when I would go to a conference, especially a social media conference, people would complain that 90% of the papers were looking at Twitter. And that meant that we were not really studying communication in social media. Instead, we were studying a new breed of science called Twitterology, where all the insights we were getting was basically about Twitter. And I think that that is a real concern. And in fact, I know that the incoming editor for JCMC, Journal of Computer Media Communication, Nicole Ellison, is particularly interested in how can we come up with theories that give us insights that transcend specific platforms, whether it is Twitter, whether it's Facebook, whether it is TikTok. So that is certainly something that's important, because the cautionary note is that we always look for theories where the data is. That's like the drunken man who may have lost the keys to his car anywhere, but will always look for it under the lamppost because that's where the light is. I want to add to this that my good friend and mentor, Scott Poole, has said that while that is true for data, that is also true for theories. If we look at the way we, especially amongst grad students, this is who I'm inviting and calling on. Very often grad students will say, if I want to explain a phenomenon, I will only look to explain it based on the theories that I was taught previously. And as a result, we are now acting as a drunken man crawling around on hands and knees under a lamppost, not just because the data is there, because that's where the theory is. But that precludes us then from looking at new opportunities of reimagining new theories. So with that, I want to pivot a little bit and talk about some specific empirical examples that take into account some of the work I've talked about. One big area is how Google is using people analytics and how it is inventing itself. So some of you may not have heard the word people analytics, but Google has really popularized it. It basically says, it takes the old HR function and says, if you make it data infused, algorithmically infused, what you get is people analytics. So this was an article published in 2016 in New York Times Magazine, what Google learned from its quest to build the perfect team. They spent 2 years studying 180 teams, the most successful ones, they said shared 5 traits. And so this is Google doing what it does best, analytics. And what they found was the number one ingredient that made a good team was if people had psychological safety. Put in simple language, if people felt safe to be vulnerable, to take risks, and do that openly in front of each other, that was an important quality to help predict successful teams. Other things on the list were things like dependability, meaning, impact. All of these were focusing on individual attributes of people. So in response to this, and because we have a network spirit in our heart, my colleague Paul Leonardi, who's at the University of California in Santa Barbara, he and I published an article in HBR in 2018 titled Better People Analytics, Measure Who They Know, Not Just Who They Are. So while people analytics typically has focused on individual qualities like psychological safety, we were saying it's better if they look at not only the individual attributes, but also the relational analytics skill. And so on the basis of this, we made the case. It's very simple to compare it to the MRI of the brains. When we look at a brain, we can see on the left what is the structure and the images in an MRI of a healthy brain, and on the right, how it looks different for a brain of somebody who is afflicted with schizophrenia. We argue the same kind of thing can apply to study networks, where if we, instead of looking as a microscope for neuro, we think of it as a macroscope. Now, we don't want to be too close to the data, but we want to zoom out. As we zoom out, what looked like a blurry picture now becomes like a pointillist painting by Henri Matisse, where we begin to see the forest from trees. And this gives us the opportunity to be able to look at all the data that we've been generating from organizations, the kind of digital exhaust data that I talked about earlier. And our goal then was to see, could we actually predict what happens in this data? So just to give you clarity, employees are sending messages, they're sending files, they're recommending and badging other people, they're liking other people, they're sending mail to other people. And as this data becomes greater and greater, we begin to see certain structural signatures that we can put to good use. These signatures that we see in that data allow us to see who is a person who's going to be good at ideation if they have a signature that looks like this. This person here is high in ideation because they're talking to people who don't talk to each other. This person is high in influence, not ideation, because they can influence a large number of people. And you might go, why is this person influential when they're only talking to 2 people as compared to this person who's talking to 5 people? Well, this is a measure of influence, not based on the number of links you have, but it's the links that you have to people who have a lot of links. Put shortly, this is exactly the same algorithm that Google uses for its PageRank algorithm. So that the top search result is not the one connected to the most pages, but it's the one connected to that's connected from the most pages, each of which in turn are connected from the most pages, and so on and so on. So that's a measure of influence. At the team level, we say if you see a signature like this for a team, where these people are in a team and they all talk to each other, they're all well connected, it means they're more likely to complete their work efficiently, but not necessarily creatively. If you want to look at creativity, you look at this one here, where these team members are creative, not because they're connected to each other, but they're connected to very different people on the outside, which then allows them to bring a diverse set of ideas inside the organization. And then finally, at the organizational level, you see silo structures, where you see these departments are siloed because they're all talking amongst themselves. And the vulnerability signature is when you find that there's somebody outside the organization who's talking to people inside the organization who don't talk to each other, and therefore create a sense of vulnerability because someone on the outside can combine ideas from inside the network, which these people are not able to do by themselves. We believe that because these kinds of signatures, these signatures have existed now for decades, there's nothing novel about it. Combine these signatures with the kind of digital exhaust data that we are getting from social media, and now you can begin to see how to make relational analytics actionable for organization. So the organizational level, it becomes actionable because we are able to use it to study not just diversity, but inclusion. Diversity metrics today have become quite popular, prevalent in many parts of the world. And many organizations will show you a scorecard, a diversity scorecard. But what is still missing is that inclusion metric. Just because you have 5 diverse people around the table, that doesn't mean you're engaging with them and they're engaging with you in the actual deliberations and the interaction. The ESM data, the digital trace data, the structural signatures we talked about give you the ability to go beyond simply looking at the diversity in the demographics of the individuals, but the actual relationships. There was an interesting cartoon where you have a woman sitting at a table along with 4 men, and she says something and they all ignore what she says. And then 2 minutes later, a man on the table says exactly the same thing the woman said. And everyone looks at the man and says, that's a brilliant idea. That's the kind of issue we want to be able to understand through relational analytics. Succession planning. Most of our succession planning today is based on looking at individual resumes. We've built a case study where we give people an individual resume of 4 candidates and ask them to choose who should be the successor. And then we ask them to repeat that exercise. But now, in addition to giving them just the resume, we give them a dashboard called the Relational Analytics Dashboard that I might be able to show you briefly what it looks like. It's a dashboard that allows them to look at the networks amongst these people. So that today, when we say, yes, I'm going to offer X a job because of their resume and because I think they know a lot of people, now that can be made much more concrete and discussed. And then finally, post-merger integration. We've already seen several instances where we spend enormous amounts of money trying to see how to make a merger or an acquisition more successful and seamless. It goes without saying that overwhelming majority of mergers and acquisitions fail, or at least fail to be as successful as they could be. We think that being able to use the structural signatures from these contexts will give these organizations that are merging, or which one is acquiring another, the ability to see who are the key individuals in each of the parent networks that can be brought together effectively to help make that seamless acquisition or integration. I say we believe because all of the 3 examples that I've listed on this are areas where we are beginning to do work to see the extent to which the inclusion metrics can be captured. Succession planning can use networks, and post-merger integration can use networks. On the next slide, what I'm going to talk about is not we believe, but we have demonstrated how relational analytics can be made actionable for teams. And I'll try to see how many of these examples I can go through very quickly. Again, the basic premise we could have done this in the past with survey data, but the problem is that they were time-consuming, they were eliciting low response rates and would go rapidly obsolete. Today, thanks to digital trace data, we are able to get those at minimal cost with 100% response rate, and they get updated 24/7. So here's an example where we asked ourselves the basic question: can we actually predict what people would say on a survey using enterprise social media data? So this is research that is done by students at Northwestern, as well as our colleagues at Fudan University in Shanghai. And what we did here was we collected data. One example of a study we did, we collected data from 66 employees at a Chinese company that use an enterprise social media platform, not unlike Slack, but it was not Slack. And we collected both digital trace data as well as survey data shortly after we collected the digital trace data. And the goal was, could we take the digital trace data and predict what they would have said in a survey? The survey asked questions such as, for each person, who provided you with a sense of purpose? Who did you rely on for leadership? Who do you go to for help or advice at work? The ESM data was what we just said. Things like who you send messages to, what time, what was was it an at mention? Was it a direct message? Things of that kind. And we built network analysis models based on exponential random graph to predict the probability that one person might give a survey response for who they look to other for relying for leadership or for advice. Again, an example of the kind of analysis we did, asking people, who do you think that an employee who sent one message per day was 15.2% more likely to say that the person provided them with a sense of purpose than those who did not? People who sent some 10% more messages to a person than they receive from that person are 26.7 times more likely to say that a person provides them with a sense of purpose. The bottom line is, we got really excited because whether it was in the case of sense of purpose, whether it was for granting leadership, whether it was for advice seeking, we were beginning to do a pretty good job of being able to take just the base of how much people said to each other, what is the relative amount of communication people had with each other, how quickly one responded to another. All of this is just metadata, not content, but just the metadata. And we were able to begin to move from not only modeling it to predicting social relations. This is an example where the question was, this person provides me with a sense of purpose. Our statistical models were providing as much as 89.46% accuracy. Some might think this is a little scary to see how much accuracy can be done by simply looking at the metadata. Of course, this is for those who are familiar with precision and recall. It tells you that the proportion of predicted ties that actually exist, or the proportion of existing ties predicted by models, kind of like the type 1, type 2 errors that we are used to, and it gives you a precision recall plot. So the accuracy figure may be a little more misleading by being so high, while these numbers can be potentially lower. But the bottom line is, whether it comes to relying on leadership, advice for work, all of these are able to begin to show that we can take the ESM digital exhaust data and use it to come up with networks amongst people in a relational analytics dashboard like this, where the data that you're seeing out here looks like it is survey data about who talks to whom, but it's really inferred survey data based upon the digital exhaust that they're generating from their machines. And this is exactly the kind of issues and platforms that are being developed by a lot of the same platform developers who have created the enterprise social media, who are now seeing that that data they're collecting can be repurposed to provide organizations and the employees within the organizations insights about what they are, their network, what does that network tell them about their ability to influence other people, to come up with good ideas, for teams to be efficient, for teams to generate buy-in, for example, for teams to be creative. And you can see a lot of these are examples of platforms that are able to understand how you can design a high-performance team. You can take a multiple set of people, put 3 of them into one option, put a different 3 of them into another option, and see how these 2 teams are likely to be different in terms of their ability to be efficient and creative. And so if you have a bunch of people who you think are all pretty good, but you can't decide which ones to put, we now have the ability to use these tools to do that. The next example I'm going to tell you and rush through a few more here in the interest of time in the last 9 minutes we have here is the idea of self-designing teams. How many times have we been in a team that turned out to be a dream team? But then how many more times have we been in a nightmare team that looked like this? And most of the time in a virtual platform, it's difficult for me to see a show of hands, but if I ask people to show hands, you would normally see about 15% of the people raise their hands and say they've been on a dream team, and 75% of the people raise their hands and say they've been on a nightmare team at some point. Here is a study that I did with one of my former students, Marlon Twyman, who's now on the faculty at the Actionable School at USC, home to Jack and myself. Diego, who's wrapping up his dissertation this month, next week actually, at Northwestern, and starting a postdoc at Kellogg, followed by a faculty position next year at Notre Dame. And then another former student of mine, Jackie, who's a postdoc at HBS. And the question we asked ourselves is, how do we design teams? Remember earlier I was telling you about algorithmically formed teams, and when people had information or people had agency in forming their teams. So we asked that same question that I alluded to in that concrete example earlier. How do people search for team members? Who is it that they invite? And so we created a network of just to find out who is it that you invite to be on a team, irrespective of whether they said yes or no. And what we said was we wanted to understand the invitation process because we want to see how technology can alter it. If we give people algorithmic recommendations, how does it change the invitation process? And so for this, I'll very quickly at a high level say that we did a study where we looked at students who were from 2 different universities jointly doing a class on assembling a project team. So some students were in ecology, others in social psychology. They were required to have members from each team. The goal was to simulate an advertising campaign to mitigate an environment sustainability issue. They had 1 week to assemble teams using the My Dream Team platform that I showed you. In the first sample, we had 213 participants that assembled into 32 teams. In the second sample, we had 197 participants that assembled into 31 teams. They used the platform we talked about. They responded initially to personal surveys, just like you would do on a dating app, and said, what kinds of team members I would like. And then they would be shown recommendations of people that they might want to look at, and you see why those people are chosen. And if they click on it on this button, it would send an invitation to people. Relatively simple. Our goal was who invited whom after they had used the tool. And what we found was exactly what I already gave you a preview. So I will not go into this in detail, other than to say we found that the recipient with the top 10 recommendation clearly had a greater chance of being invited. Somebody you previously collaborated with had a better chance of being invited. But more importantly, there was an interaction between if you previously worked with someone and the recommender system recommended them. And that what I said earlier was that if a person showed up in the top 10, the increased likelihood that they would get invited is much higher in the blue condition, which means that you did not previously collaborate with them. It is higher, but much less higher. The slope is much less steep for those that you previously collaborated. So again, as I mentioned previously, if you previously knew somebody, the recommendation is not as influential as if you did not know that person. The same thing was true in the second sample. And then I'm going to go very quickly through the next few examples here, rather than in the interest of time. This one is we go to space for this. And as you know, that humans are on the verge of becoming an interplanetary species. We plan to get to Mars by 2033. And NASA has made a big commitment to this idea. And it's interesting to think about going to Mars, because if ISS, the International Space Station, is 250 miles, the moon is 250,000 miles, and Mars is 250 million miles. So you begin to see we're talking about orders of magnitude in distance. That means a trip to Mars is going to take 259 days. And because of the nature of when Mars and Earth are close to each other, there are narrow windows during which we have to send space capsules to Mars. Remember last year, it was the month of July when all 3 spacecrafts left Earth to go to Mars, from China, from the US, and from the Emirates. And again, they all landed in Mars in a small window around February of this year. So you get a sense of how this works. So if we were to send humans to Mars, it's going to take approximately 9 months to get to Mars. It's going to take about 6 to 9 months, depending on the speed of the rocket. You have to stay on Mars for a year before these dynamics make it likely that you can sling back to Earth. And then you take about the same amount of time to come back. So you're putting as many as 6 international crew members from different cultures in a small confined space for 3 years almost, with no voluntary chance of getting of being able to exit. And furthermore, as they get closer to Mars, the distance between Earth and Mars means that it will take as much as 22 minutes for a message to go from Earth to Mars, which basically means that if you say, Houston, we have a problem, you may have to wait 45 minutes before you get any response back from Houston. So you have to work autonomously as a team. You cannot rely on mission control as we've done. And so what we did was, in the old days when people were going to Antarctica, they put ads saying men wanted for hazardous journeys, small wages, bitter cold, long months of complete darkness, constant danger. What happened was they got people who went to the Antarctic station, but these were people who were deficient in social skills. These were people who wanted to get away from Europe because they had nothing else to do. They're like, well, last year I might as well go to the Antarctic, and if I succeed, I might become famous. That's changed. If you think of the people at the space station, there are diary entries from astronauts who talking about their commanders say, the commander is brilliant at knowing the perfect balance of fun with professionalism. Space has now become a place for the interpersonally gifted. And so we were interested to see what predicts how people would interact in space as a team. After all, astronaut Captain Scott Kelly, who was amongst those who spent the longest time in space, when he came back from the space station, says it's teamwork that makes the dream work at NASA. So what happens to teamwork under extended periods of isolation and confinement? Well, what we have a situation is the dilemma of the team staffing that I was telling you. You have crew commander from Russia, a flight engineer, say from Germany, a payload specialist from India, and you want to see which American will fit best with all of these people. So how do we go about starting this? Wouldn't it be nice if we have a human petri dish where we can put people and manipulate their isolation and sensory depression for hundreds of days while making them do complex and boring tasks, monitoring them 24/7? Those of you who have research and familiar with the American Institutional Review Board will say this will never get passed through an IRB, and so you will not be able to do it. But that's actually exactly what we're doing. And it's because NASA and other analogs and space administrations like that have created a human exploration research analog. This one is called HERA. It exists at the Johnson Space Center. They put people into confined spaces like the one you're looking at for 45 days more. They're about to start one that may go on for an entire year. We are not Americans, not alone. The Chinese have a facility called the Lunar Palace. The Russians have a facility called NEK. We've actually collected data here of a group that was put in there for 120 days. And we're about to start a project where they're going to be put there for 240 days starting this November. JAXA has its own isolation chamber and so on. In the interest of time, I'm going to say that we collected data of the kind you're seeing here, where we asked each person at multiple points in time. So this is day 1 of the mission. This is day 45 of the mission. Who do you get along with? The green links, with whom do you work with effectively? The orange links are who made tasks difficult to complete. If you look at the orange links, you'll see that this person at the bottom here was clearly seen as a hindrance by everyone else in the team, but that person didn't think other people were hindrances. Our goal was, could we have predicted that this person would have been seen as a hindrance by other team members if we had good computational models? And so we built a computational model using theory, prior empirical research. We used the data that we were collecting in the model to parameterize the computational model. And then we began to do virtual experiments of the kind where you can see if I can get this to work. It's basically, I couldn't, it's a computational model of the kind that I was just mentioning to you, that we saw these little things changing. And then we were able to see that it made sense. People who were good at self-monitoring were more likely to be viewed as someone who people enjoyed working with, while those who, as the workload increased, you thought that your ability to work well with people would go down. But we had so many different metrics, and we did something great. We predicted how well these people would do. Again, our predictions were very good. I don't have slides on this, but in addition to prediction, NASA said, can you prescribe what will happen? And it's not enough to tell me that A and B won't get along. Can you preempt and fix that problem? And we did that more recently in data I'm not talking about here in the interest of time, since I'm already over. I might go 4 more minutes, Jack, and then I'll seat the rest here, just to give you a heads up. But what it said is that it's not enough. We were able to predict and then preempt problems in the team by taking people who were paired together, who we thought were not getting along, and to repair them with other people. And so, as we like to say, we were repairing individuals and tasks in order to repair their relationship. So I was very proud of that play of words. So very quickly then, how do we predict team performance? For this, we turn to sports. This is an article we published in Nature Human Behavior, where lead author Satyam, being Indian, was really fascinated by cricket and was interested to see how could he predict which team would do better than the other teams. So he began to look at cricket teams to see the stats of the individual players, and I'm going to rush through these slides. And he found that the stats of individual team players did not provide a good explanation for why, for example, the Kolkata Knight Riders who had 2 players from India and the rest were all-star players from Australia, South Africa, and New Zealand, was not doing as well as the Chennai Super Kings, who had more championships and playoffs, where 6 players were from India. These were not superstar players from the world. Why were the Chennai players doing better than the superstar players? The answer, my friends, lies in the fact that these players had better networks. They had played together previously, and that network ties that they had amongst themselves was a better predictor of which team would beat another team. Not only did we do this in cricket, we replicated this in this article in Nature Human Behavior. We replicated those results with NBA, soccer, the English Premier League, baseball, Major League Baseball, and even an online game called Dota 2. In every case, the basic idea is that the team where people have better network ties, having played previously, was more likely to beat the other team, even after taking into account the individual stats of the players in the 2 teams. And then I'm going to end here with an example that talks about predicting team conflict, that talks about going back into space. So many of you may not be familiar, but this is work I did with my former postdoc, Michael Schultz, who's now a faculty member at Indiana, and we wanted to predict conflict in space. So again, what do we mean by conflict in space? Some of you may have heard of something called Skylab. It was the first American space station that happened between the Apollo missions and the space shuttles. Today, not talked about too much, but it was, in fact, America's first space station. And there were 3 of these manned missions that happened. And we wanted to see what was the mental models amongst these people. Each of these manned missions had a commander, a pilot, and a scientist pilot. The first mission lasted 28 days. They worked in space, did solar observations. They had some really difficult technical difficulties to overcome. The original Skylab 0 that had gone in space by itself without humans had serious problems with their solar winds. These people went and fixed it. The second mission lasted 59 days. Again, they were able to do a lot of biological experiments, did a lot of health research. It was super efficient to the point where NASA now began to get high expectations for people working with these space stations because Skylab 2 was super efficient. And then came Skylab 3. This was the first time they sent 3 novices into space who were all on their first rookie season. It was 84 days. They had a lot of space sickness. More importantly, they tried to hide their space sickness from people on Earth. They got caught, they had a lot of tension, and they had the first mutiny in space. You may be interested, people wrote that this was the first time astronauts went on strike in space. The commander of the mission said we would never work 16 hours a day for 84 straight days on the ground, and we should not be expected to do it here in space. There was a Wikipedia entry called Skylab Mutiny. Harvard Business School wrote a case called Strike in Space. My goal here, Michael Schultz's goal, my postdoc's goal was, could we have predicted this conflict in space by simply looking at the data transcripts that were happening? So he went back and looked at all the air-to-ground communication, 15,000 pages of spoken communication, 3,800 tapes, identified time, speaker, and the verbatim utterance, did topic modeling to see what were the topics that a person was doing, built up their own mental model of what words they associate with each other, then built a network of mental models to see how did my mental model overlap with another crew member's mental model, or overlapped with mission control, the crew, which is the Capcom, which is the red box here, which is the mental model. And what we found was that if you look at it, Skylab 1 had a lot of crew similarity, a mental model similarity amongst themselves, and also with intra-crew, but also with Capcom. It's pretty high, while Skylab 3 had the lowest. So they didn't have a good shared mental model amongst themselves, nor did they have it with mission control. And we see how it develops over a period of time. Bottom line is, we were able to predict, retrospectively, of course, that Skylab 3 would run into a mutiny because 11 days before, the day 46 when they had the meeting, 11 days before that, their mental models were already getting to be out of whack with one another and with crew command. So again, I just want to close with the 3 or 4 slides here on the article that we published in Nature. These slides, this is the article that Claudia was the lead author, and the slides I'm about to show you are also slides that she presented at the recent Networks 2021 conference. Observation 1, the subject of investigation has changed for social scientists. Algorithms are now being used in social processes, are being used by platforms, economic processes are being influenced by platforms, political processes are being influenced by platforms, and algorithms are changing even the way we do science in this context. So we are witnessing the emergence of algorithmically infused societies. We begin to see that this is now creating an example of loops that are changing how we behave, and then how algorithms are changing the way we behave, and then how algorithms themselves are changing as a result of what is acceptable. Observation 2, the scale at which measurements can be applied is new, and granularity of what can be measured. Relational event models that we talked about is an example. So it's challenging but important to identify, quantify, and rectify what the consequences of measurements are. The challenges of measuring algorithmically for societies and future research direction has 3 problems. First, the quality of measurement models. We don't have established quality standards. Computational methods often fail to make their assumptions explicit. Data sets that are used to develop and evaluate these models often fail to capture the construct of interest or to justify the data selection. How do we address it? Triangulation of data is more important than ever, developing guidelines and best practices to increase the quality of measurements. I can imagine many of you who are here in this presentation have loads of questions about how do we collect this data? How ethical was it? What are the ethical implications? This is why we need to be thinking of this. The second is the consequences of measurement. Measurements may alter behavior, but they can also become a tool for self-improvement. But at the same time, there's a trade-off between privacy and transparency. What if my network diagrams were incorrect and I thought that somebody was not influential when they were influential because I was collecting data on Teams and they happened to be using WhatsApp or WeChat? So we have to think about the ethical reflections and the participatory approaches where we include the participants to see what it is that we are studying and to point out our errors to us. And then finally, there are limits of social science theories. We're often not developed with these deep societal reach of algorithms. And so thinking of what it means to think of theories, can we even have a stable theory when algorithms are constantly changing how we behave, and then algorithms in turn are changing as a result of how we behave? It's almost like some would argue trying to sew buttons on a jelly bowl, for example. So we have to think about these issues and have a conversation overall. Thank you very much again for giving me 9 more minutes. I apologize for going over the top, but I want to just make sure that in addition to acknowledging all the wonderful students and postdocs and former students in the Science of Networks and Communities Research Lab, I also acknowledge some of the funders who made this research possible. Thank you again for giving me this opportunity to share these ideas with you.
Thank you so much, Professor Contractor. Okay, listening to you brings back my fond memories of 20 years ago. This is so typical of Noshir, okay, being very efficient, but also I didn't feel like it's 1 hour long, all right, and I feel like 10 minutes and covered so much. Okay, from I was expecting to hear a lot about teamwork, okay, but less so about the neural space and not about the outer space. That was something I did not expect, but I really enjoyed, and also the cricket, okay, analysis too. So we have 20 minutes for Q&A. There are already 4 questions. So if you have a question, please feel free to type into the Q&A box, right? One of them, let me just go to the straightforward one, is number 3. Gui Herman is asking for the paper, okay, about predicting interpersonal relations using ESM. Okay, if that could share.
That paper was published in Complex Networks, and let me see if I'm able to find it while we are chatting. I might put the link in.
It's okay. So Complex Network is this year?
Complex Networks, I think it was in 2019 or in 2020 is where we published that paper. Look for the lead author being Brennan Antone, and he's finishing his PhD, and he's the one who has been working most on that particular issue. Yes.
All right. Okay. So yeah. So I hope you can find it in that journal. Okay. Let's get back to
email me about it, and we'll take it.
Sure. Yes. And then let's get back to the first question. Okay, it's from Ji Wei, our colleague in East Asia Institute. Will employers and employees gain the algorithm by misreporting information? Okay, because this is a key advantage when we compare to survey. Okay, it's quite easy for a survey to collect people giving like a socially desirable answers. But what about ESM or these other scenarios that we work with?
Yeah, I think that is absolutely a concern, and it is not a new concern, by the way. That when people, just to take you back into history, some of you may have heard of Bell Labs at AT&T, and the team that was in charge of coming up with Unix, they created a system where in the old days on Unix, you had something called a finger command or a PH command, which said that if you want to find out about someone, you can finger that person, you can do PH, which stood for phone, and put that person's name and it would tell you something about it. Though that team decided, this is a great way for us to find out who knows what. And so in that little finger, in addition to their name and address, they would put their areas of expertise. What happened? People who put their areas of expertise in an area that was not very well known by other people, many people came to them for advice. And they were being very helpful to their colleagues, but in the process, they were not getting as much of their own work done. So when performance appraisal time came, they were told, yeah, but I didn't get as much of my own work done, but look, I helped all these people. So they changed the system and said, every time that you ask someone for help, click on a button and you'll know that that person helped you. So guess what, Jack? These people gamed the system. They would all ask each person to help one another so that everyone's numbers went up. And then the next thing they did was, oh, but you may get a lot of asks, but how well did you actually answer their question? It's not enough just to get asked questions. So they tried to tweak it again, and people gamed that system. So the idea of gaming a system is built into these ideas, and part of what we need to do is to recognize that we have to see ways in which our system is not artificial. I mean, I don't know whether this is true or not, and it may be very dangerous for me to say this to an Asian crowd, but I had a former student from China who said that when the government was faced in some city with a rat infestation, they offered to give people money if they brought in dead rats. And what that resulted in was some people now created a farm of rats where they raised rats in order to go kill them. I'm not taking any claim of veracity, and so we can take that as a legend, but it does reflect a human nature, not necessarily a Chinese human nature, but human nature to try to game the system. One other thing, though, I would say, and this was true of some of the work that Sandy Pentland's group and his colleagues have done as well, is that people are mindful and aware of these badges and other monitoring for a period of time. But they seem to get a point where they are no longer able to cognitively constantly monitor this, and they almost forget that these things are around, sometimes to their detriment. It's like how often, we in the Zoom world have learned of embarrassed moments where we forget that the camera is on, we forget that the microphone is on. And so even though people have this instinct for gaming the system, a lot of the work seems to show that after that initial enthusiasm to do it, that seems to be tapering off, again, for better and for worse. But it's an excellent question, and it's one that is not leaving us anytime soon. The same thing is true for algorithms. We also game algorithms. I remember a few years ago when an algorithm was looking at screening applicants, and they said, let's look for Ivy League schools. And so this was told to me by the person who developed this algorithm for Intel, out of the Phoenix office, who said, well, all of a sudden I started getting applicants from people who would put into the application, I did not get my degree from Princeton, Cornell, Harvard, Stanford, Penn, Columbia. I got my degree from this small college, but the very fact that they had the names of all those Ivy League schools, they had gamed the system and they would be rising up to the top of the list. So yes, I think that we have a long history of this, and we will have to continue to play whack-a-mole, if you may, on this front, where we keep looking at new ways in which people are going to game the system and try to knock them down.
Yes, absolutely. And I think this is also in, because I also spent some time in TV audience studies, like when Nielsen started to track TV rating, they don't count the first month when they put in the monitor device, and only after the second, yeah. And also, if you used ESM, like if you're on Slack, okay, working with like in order to game the system, you need extra time. There's a lot of work, okay, to coordinate, right? So I think after that, it's very important to keep it in mind. But it's much harder to game this digital exhaust, measurement compared to survey, right? The survey is much easier to get, but then there's always a difference in terms of degree. So the next question, also from Gui Herm, is about, I think not sure you addressed this second is the long one, right? You towards the end, what you called external validity. Okay, but here, Guiherm is mentioning is okay about criticism against repurposing digital data for analysis that is not representative of the target population, right? So
yes,
and then do we need to get new theories, okay, completely new things for these new kinds of data, or there are some fundamental limitation in repurposing, okay, data repurposing, and what are your thoughts on this?
Sure, that's a very, very good question. Thank you again, Guilherme, for asking the question. There are two parts to that question as I see it. The one is the issue of repurposing. And I think we are increasingly moving away from taking data that was collected for some other purpose, such as debugging, and using it for this. And that has some real challenges. One of the things that I'll tell you, since now you know a little bit about my interest in studying teams, when we looked at the original online games like EverQuest 2, and in that game, if you're not familiar with it, each person has an avatar, and then they join together in teams, and then they go kill a monster. And when they kill the monster, they get more wealth in the game, which they can then use to wear fancy virtual clothes and buy a fancy virtual house and things of that kind. Okay, so clearly in this, they were engaging in team activity. It turns out that the kind of data that we had that we were repurposing did not ever log who was on a team with whom. And we're like, why would you not do that? And we went to the people at Sony and they said, why would we do that? That was not important for us in terms of debugging any problem we had in the game. And so we had to spend a lot of time creatively reconstructing what a team looked like by saying if two people were at the same virtual coordinates in the game at a particular point in time, and they both engaged in some killing activity or some earning activity, and a third person was also there, we were literally reconstructing teams by looking at their location at a particular point in time, their spatiotemporal orientation, if you may, in order to do that. That had a lot of problems. So I think part of what we want to also understand is that repurposing is a big problem. Today, it's less of a problem because companies and organizations like Microsoft Teams with the Viva Insights, for example, have realized that this is not only about debugging, it's a feature by itself. And they have now instrumented the workplace, instrumented platforms in order to collect a lot of data for the sole purpose of, in some cases, market research, in other cases, also feature research, as well as social science research. So that was the first part you were asking about repurposing. The second part of the question was, well, what do we do when people might use multiple platforms? And this is a real challenge, but one that has been taken on by a lot of people. And so today we find that most of the current research that I think is the most exciting in the area of social media is taking on the challenging task of trying to connect across multiple platforms. This is still in its very early stages. I know that there are some people who are doing this to study social movements around the world, COVID discussions around the world, but doing it across platforms like Twitter, but also combining it with what they can from things like Instagram and Snapchat and Facebook. It is not easy, but I can certainly tell you that there is now movement in that direction, and there are new papers that are emerging just within the last few months where people are developing very creative algorithms to be able to collect persona across these, or at least at the aggregate level within a certain area, begin to see whether there is activity moving from one platform to another. Another good example in other parts of the world, not so much in the US, is the use of Telegram. The same thing has not yet been applied in the enterprise social media, I'm sorry to say. And indeed, when we went to the company in China and presented some of the same results that I shared with you today, I do recall that while standing in line for lunch, this was pre-COVID, so we were all huddled together, standing in line. Some of these employees came to me and whispered softly into my ears, "You should know that if there's anything really important to say in the company, I'm not going to use the company's ESM platform to do it. I will use my private WeChat channel to be able to have those conversations." And so I will be the first to admit that these results are definitely limited in terms of what they're doing, which is one of the reasons why I think, we have to understand that we have to handle these with a lot of caution, with a lot of trepidation. It doesn't mean that they are not providing some insights, but they could be glaring omissions. One way, Jack and Guillermo, and where we are trying to address this is providing every employee with their own structural signatures, their own networks. They provided the data to us. They didn't see it in this form, but we do it. And we do it with the purpose of helping empower them so that they begin to see that they are benefiting from it. They are not simply being, people observed in a glass bowl and nothing is done for them. We tell them, your ideation signature is so-and-so. In some cases, it's higher than what they thought it was. They don't leverage it. In other cases, we tell them, here's what it is, here's what you can do, here's what you can do if you want to make it better. But a second intention of doing this is we tell them, if you think this number is at real variation with your personal belief, please bring it to our attention. Because that might allow us to see that we had made some error about looking at their network based on the platform we looked at. We compare that to looking in the United States at what are called as credit rating scores. Every American has, based on their use of credit cards and other financial transactions, has a credit rating score that is compiled and computed by companies like Equifax, for example. And you can always get it. But sometimes you go and ask them for your credit rating score because you're afraid that somebody has impersonated you and has taken over your financial identity. And in those cases, people have recourse to go back and find out, no, this is not who I am. Somebody else is operating under my name or my social security number or my credit cards. We believe a similar strategy when applied to individuals where people have recourse to being able to say, look, I think there's something wrong with what you've given me, is one way in which the system can become a self-correcting system.
Yes, I think this also, goes, just follow up, piggyback a little bit on this one, is that I think in the question, right, Guilherme asked about the target population, right? I think it depends on what kind of team also, right? Like whether they're in China, they have multiple choice for social media, okay? Or they're in Skylab, okay? All the communication, they cannot choose to use other means of communication, right? And also the idea, I think this is a critical difference between my understanding as organizational analysis and social. Okay, when we talk about the social representativeness, right? And but here, when that analysis among astronauts, of course, astronauts is another kind of undergraduate student. They're captured, right? And you cannot do, but then, why do we don't need to, generalize from this Skylab team to other astronauts? You don't need to care. You only need to care about the dynamics within that. Right. So I think it depends on what kind of team and in what kind of communication environment, right? And ESM can be different. Telegram, by the way, Telegram is very popular in US students. I realize that. Is it? Yeah, yes, too. Yeah. Okay, so next one, I think from Bing Ke, I think you also mentioned this towards the end of your sharing. Is that about privacy concerns, okay, using ESM data, and also about, because Bing Ke is asking two questions, but both of them are short, again, about the limitations of ESM to study teams. Does that mean, when you talk about triangulation, does that what you imply is that in addition to ESM, digital exhaust, you also need to do interview or other kind of, is that right?
Absolutely. That's the triangulation part of this. And in fact, Bing Ke, these both very, very good questions. Thank you for asking these questions. I think one of the things that I always have argued and believe very passionately is that computational social science is, as I like to call it, one quiver, one arrow in the quiver. It's one arrow in the quiver. It's not the silver bullet. And frankly, I don't think I know of any computational social scientist who really believes that it's the be-all and end-all of these different issues. I mean, I think over the years we've seen, and we should continue to see, that we might specialize in certain areas as individuals, by the way, but that doesn't mean that we can work to solve societal problems based upon a single method or a single theory. I mean, one of the things that I talk about in general in the field of science today is that, and Jack sort of alluded to this, the real fundamental importance of interdisciplinary work, because societal problems are getting more and more complex. And these complex societal challenges that we have, they don't know disciplinary boundaries. They don't know methodological boundaries. And as a result, any serious effort to address these problems requires a diverse set of disciplines and methods and tools, along with computational methods. I'll give you a simple example of a computational method benefiting from qualitative research based upon the online game study that we did. In the online game study that we did, we were looking at how teams were forming, Jack. But again, there it was teams that were going on quests to go kill monsters. And who was playing games with them. And one of the things we found was that males, that we looked to, there was a lot of homophily. Geography was a big one. You would not think that's true in a virtual world, but it turns out that you were enormous 25 times more likely to play online with someone who was within 50 kilometers of you than between 50 kilometers and say 400 kilometers of you. So even though virtual games allow you to go online and play with anyone, the bottom line is you still played with people who are close by to you online. The other thing that was, so we found age homophily, you played people of the same age as you, so there was a cohort effect. But the one we were most puzzled was with gender homophily. We did not find overall strong evidence of gender homophily. When we parsed down, we found that men like to play with men, but females were not particularly likely to play with other females. They often played with men. And we had this finding from computational model of large-scale data, terabytes of data. But we didn't know how to make sense of it. We had ethnographers on our team. And in particular, one, I remember Tracy Kennedy in Canada, and she was part of our team. And she went to do what we now know as ethnography, right? Ethnography on the net. So she would go and talk to these people and observe them, et cetera. And what she found was something we would never have found by looking at only computational digital traits data. What she found was that there were a few women who played the game who were really passionate about the game. But the majority of women who were playing the game were only playing it because they happened to be the significant others of men who were absolutely addicted to the game. And so the only way they would ever get any time with their male partners was if they decided to go along and play these online games with them. In the United States, we have a term called football widows, where during the football season, men are so addicted to football that their wives become football widows. The same phenomena was happening in online games. And so the reason we had this empirical observation where men like to play with men, but women also were not particularly interested in playing with women, they would often play with men, is because the women who were playing with men were doing it out of duress. It was the only way they could maintain their romantic relationships with the men. So that's an example of where you have to think. It may be a trivial example, but it's still, I think, a very revealing example of the limitations of just using one approach.
That's a really interesting way to end today's keynote speech. I know of Kennedy's study, but just now hearing you say it again, it reminds me of the Big Bang Theory when they talk about the wives and the girlfriends, playing game because of their significant others. So I think that could be a very vivid, all right, audio visual footnotes. Okay, for us to end today is not only about serious work in teams, but also partnerships, and friendships, and also even in entertainment, sphere of gaming. So I know it's getting late, and I want to thank Professor Contractor again. Sorry, we cannot answer all the questions. I hope Guilherme can find that article. If you still
send me an email, Guilherme,
yes,
and I'll send you a copy of the article for sure.
Right, yes.
I appreciate your tenacity.
Yes, because he's working on very related topics. So I think this is
fantastic.
Wonderful. I have learned a lot. Some of the things I learned in the previous hour, I will use in my teaching tonight, maybe including the game part. So thanks again. Thanks so much, and thanks everyone for coming. By the way, I want to also salute to everyone who stay with us, because actually we had a very fierce competitor. A vice president Kamala Harris is actually giving a
know.
virtual talk in NUS as we speak. Okay, thanks for staying with us. And I'm sure everyone agree with me. We have learned so much, okay, from Professor Contractor, and for that we will want to thank him again. Thanks.
Thank you all. Thank you, Jack, for
night.
inviting me. Thanks for the great questions, and good luck with the rest of the conference. It's an amazing lineup of speakers you have there. It's really fantastic.
Thank you. Yes.
Hi, everyone.
All right. See you guys later. Bye.
Bye.